Welcome to AI Research Roundup. I'm Alex, and today is May 8th, 2025. We're looking at an ICLR conference paper published a little over 3 months ago. TANGO, Co-Speech Gesture Video Reenactment with Hierarchical Audio Motion Embedding and Diffusion Interpolation. This paper introduces TANGO, a system for creating very realistic or high-fidelity videos of a person gesturing naturally as they speak. It uses a short reference video and new audio to generate these co-speech gestures, aiming to improve on older methods like audio-driven gesture video reenactment, or GVR, which often struggle with audio-motion mismatches and visual glitches. Alright, so this first figure gives us a nice visual overview of how TANGO works. You can see a film strip with a person gesturing, and below it an audio waveform representing the speech. TANGO uses what's called a motion graph-based retrieval approach, which means it first pulls existing video clips that best match the new audio. Then, to connect these clips seamlessly, it employs a diffusion-based interpolation network. This network is a clever AI that generates new smooth transition frames where needed, avoiding those awkward jumps we sometimes see. Let's move on to the next part regarding TANGO co-speech gesture video. Okay, building on that, this diagram shows a crucial part called Hierarchical Audio Motion Joint Embedding, or AUMOCLIP. It's a pipeline that helps the AI learn how speech, audio, and body motion are related at different levels. It creates an embedding space, a kind of map where audio and motion that actually match are placed closer together. AUMOCLIP uses a two-part system called an encoder, with low-level and high-level components, and a training method known as contrastive loss. This contrastive loss teaches the AI to distinguish matching pairs effectively, leading to much better gesture retrieval. So after AUMOCLIP helps find the right gesture clips, we need to smoothly connect them. That's where this next figure, detailing appearance-consistent interpolation, or AC-interp, comes in. This module, appearance-consistent interpolation, is the clever diffusion-based interpolation network we mentioned earlier. It's designed to generate those crucial in-between frames. You can see it uses things like a denoising net, which is an AI that refines the image, along with background guiders and a reference motion module. These components help ensure the person and background stay consistent, using information from the start and end frames of the clips to avoid those weird visual glitches during transitions. Alright, moving to the results, this table presents a quantitative evaluation of co-speech video generation. It compares TANGO with other methods, including the audio-driven gesture video reenactment we talked about, on the show Oliver, and YouTube talking video datasets. We see metrics like Fréchet video distance, or FVD, and Fréchet gesture distance, or FGD, where lower scores are better, indicating more realistic video and gestures. Then there's beat consistency, or BC, where higher is good, showing alignment with speech rhythm, and diversity, where higher means more varied gestures. TANGO achieves the best scores for Fréchet video distance, Fréchet gesture distance, and diversity, showing it produces more realistic and varied gestures overall. Okay, so digging a bit deeper, this next table compares different features for audio motion retrieval. This really shows how well that hierarchical audio motion joint embedding, or AUMOCLIP component we discussed earlier, can find the right gesture clips to match the audio. It looks at retrieval accuracy for both low-level details, like fine-grained movements, and high-level patterns, the broader gesture shapes. And AUMOCLIP at the bottom significantly outperforms older methods, including those keyword or onset matching techniques used in audio-driven gesture video reenactment, with scores like 65.68% and 19.54%, which is a big improvement. Alright, so after hierarchical audio motion joint embedding helps find the best matching gesture clips, the next challenge is smoothly connecting them. This figure visually demonstrates the quality of transition frame generation. We see several snapshots comparing different methods, like Animate Anyone and Film, against TANGO's approach, labeled Hours, and the ground truth, which is the real video. The key thing here is that TANGO, using that appearance-consistent interpolation we talked about, shows fewer artifacts, especially in the hands, and maintains appearance consistency much better. Some other methods blur or even lose hands, but Tango's results look closer to the real thing. So these visual comparisons really highlight how Tango, with its appearance-consistent interpolation, creates more natural transitions. In essence, Tango offers a robust way to generate these co-speech gesture videos. The big takeaways are its hierarchical audio-motion joint embedding for accurately matching gestures to speech, and that clever diffusion-based interpolation for seamless, artifact-free transitions. It really seems to push the state-of-the-art forward. Well, that's all the time we have for this research roundup. Thanks for tuning in, and I'm Alex signing off.